don't know why it keeps getting disconnected, but okay. And as I mentioned, how the rules that apply to resistors apply here as well. So it's going to be as if we have 6 times 3 divided by 6 plus 3, which will give us 2 microfarads. So then my circuit will look like this. And again, if I do the black ones as the ones I didn't change, 2, and then the other one will just be a 2, right? And then back and forth, so these two, as it's shown in green here, they're going to be in parallel again, right? So these two will be in parallel, they add up, become a 4, basically, and then my final circuit will look like this. So 3, 12, 4, and then so that's basically going to be our equivalent circuit. And then if you add all of them up in parallel, so your C equivalent will be equal to 1 over 4 plus 1 over 3 plus 1 over 12, and then you flip that. If you add all of that up, it will be equal to 3 over 2 microfarads. That's all there is to that. And now if I go to inductors, as I mentioned, inductors act exactly the same way resistors would act. So if they're in series, they add as resistors would in series. If they're parallel, they add as resistors would in parallel. So next one is this example. It's already telling us that all of the inductances are 4 millihenry, but it wants us to find equivalent inductance across those two nodes. So let's take a look at this one. Looking at the blue ones, I know that they're obviously in parallel because they share the same two nodes. This is a 4, this is a 4. If I combine them in parallel, I'm going to get 2 millihenry, right? And then looking at the red ones as they're drawn here again, I can see that these two are going to be in parallel. So this is a 4, this is a 4. They're equal. So if I do the, 4 times 4 divided by 4 plus 4, it's going to be 16 divided by 8. So it's still going to give me a 2. And now if I redraw this circuit based on those combinations, I'm going to kind of push everything. I'm going to push this one on here, and then I'm going to push this one on here. So then if I redraw it, you're going to see what I mean by that. My circuit's going to look like this. And then these ones I didn't touch. This one is the red segment that we kind of set in parallel, and this one is the blue segment that we set in parallel. So now, if I look at this circuit and I want to combine everything, these two are going to be in series. So these are series. They're going to be parallel with that one. And then that whole thing is going to be series with this, right? So then L equivalent will be the 4 and the 2 in series. So 4 plus 2 millihenry, right? Parallel with that other 4 that's there. And then that whole thing in series with the 2 on the bottom. So if we add all of those up, parallel, series, whatever, then it's going to be equal to 4.4 millihenry. So yeah, basically what I want you to take away from this lecture, you need to know how to do the derivative integral for your quiz. But rest assured that on the final, I will not ask you to do a question like that where you have to get the derivative and integral and it's a long question. No, I won't give you one of those. If I give you something on the final with respect to inductors and capacitors, it's going to be something like this, where I ask you, okay, so this is a circuit that's only made up of inductors, or this is a circuit that's only made up of capacitors. What is the equivalent capacitance, or what is the equivalent inductance? That's all that I'll ask you on the final. So basically, the most important things I want you to take away from this lecture are: how do we combine inductors in parallel series? How do we combine capacitors in parallel series? And then most important of them all is this table. Again, for the quiz, you need to know how to do the derivative integrals, but for the final and for the rest of the class, you don't need to do all of those derivations. What you just need to know is this table and then how you combine them in series and in parallel. Okay. And again, watch this video. If you have any questions, ask me during our live session 4 to 6 on Monday. Based on how our live section goes on Monday, if you guys have a lot of questions, I can do like a 1 hour, 1 hour and a half session on Wednesday before your quiz. So I'll probably do like, I don't know, 3:30 to 5 if you end up needing it, right? 3:30 to 5 on Wednesday, and then 5:30 is when I'll give you your quiz. So yeah, based on how it goes on Monday, we'll see if we need a session on Wednesday, and if we do, then I'm gonna put it from 3:30 to 5. So watch out for that. And with that, that's all that there was to this lecture. Have a good one.